about Z-test for two proportions. Z-test for two proportions test for a difference in proportions. Unlike single proportion Z-test, a two proportion Z-test allows you to compare two proportions to see if they are the same. The two-tailed test, the null hypothesis or the HO for the test is that the proportions are the same, while the alternative hypothesis or the HA is that the proportions are not the same. For a one-tailed test, the null hypothesis or the HO is that the proportion is less than or equal to the other proportion, while the alternative hypothesis or the HA is that the proportion is greater than the other proportion. For statistical purposes, you can compare two populations or groups when the variable is categorical and you are interested in the proportion of individuals with a certain characteristic. For example, the proportion of smokers. In order to make this comparison, two independent random samples need to be selected, one from each population. For the variables that you will be using, P1 is the proportion for the first sample, while P2 is the proportion for the second sample. To get Q1 and Q2, you must subtract 1 from your P1 or P2. N1 is the sample size in the first sample, while N2 is the sample size for the second sample. Let's have 3 examples for Z-test for two proportions.
Problem number 1. A researcher made a survey regarding the proportion of male and female college students who dropped their business mathematics subjects before midterm examination. In a sample of 600 female students, 49 dropped their business mathematics subject before midterm examination. In a sample of 450 male students, 36 dropped their business mathematics subject before the midterm examination. Is there a difference in the proportion of male and female students who dropped their business mathematics subjects? Use alpha equals 0.05 level of significance. The given P1 49 over 600 divided and you'll get 0.0817. P2 36 over 450 divided and you'll get 0.08. To get Q1 and Q2, you must subtract 1 from your P1 and P2. Q1 1 minus 0.0817, you'll get 0.9183. Q2 1 minus 0.08 and you'll get 0.92. Your N1 will be 600 and your N2 will be 450. Step 1 is to define the hypothesis. HO or the null hypothesis will be P1 is equal to P2. HA or the alternative hypothesis is P1 is not equal to P2. Your claim will be the alternative hypothesis, since the problem is asking if there is a difference in the population of male and female students who drop their business mathematics subjects. Therefore, it simply means that it is not equal. Step 2, the alpha. Step 2, the alpha. The alpha is already given at the problem, which is 0.05. This problem will also be a two-tailed test since the problem is asking for the difference in the population. If the problem mentioned anything if it's greater or less than, then that will be the time that it will be a one-tailed test. Step 3 are the critical Z values. Since this is a two-tailed test, you will have two critical Z values, a positive and a negative one. Now using your t-table, locate your alpha which is in the two-tailed part. You'll get positive negative 1.960. Step 4 is to solve for the problem. Using the formula Z is equal to P1 minus P2 all over square root of P1 Q1 over N1 plus P2 Q2 over N2. Substitute the values that you have. Now your solution will be like this. Z is equal to 0.0817 minus 0.08 all over square root of 0.0817 times 0.9183 over 600 plus 0.08 times 0.92 over 450 Solving it all using a calculator, you will get 0.10. Step 5 is to graph for the value. Draw the normal curve and then plot the critical z-values, which are positive, negative 1.960. And then shade those regions. Now plot your answer of 0.10 in the graph. Since our answer did not touch the shaded region of the graph, we can assume to accept HO because the answer falls on the equal side of the graph, which is the not shaded region. If the answer falls on the shaded region, then this will be the time that it will be not equal. So therefore, we have to reject our claim and we have to accept the null hypothesis, which is P1 is equal to P2. Step 6. Conclusion. Since we reject HA, we can conclude that there is no difference in the proportion of male and female students who drop their business mathematics subject. Problem number 2. Random sample of 100 observations from the first population was to have a sample mean of 85 and a sample standard deviation of 10. A random sample of 93 observations from the second population was found to have a sample mean of 80 and a sample standard deviation of 15. At alpha is equal to 0.01 level of significance, is there a difference in the population means? The given, P1, 85 over 100, divide it and you'll get 0.85. P2, 80 over 93, divide it and you'll get 0.8602. To get Q1 and Q2, you must subtract 1 from your P1 and P2. Q1, 1 minus 0.85, you'll get 0.15. Q2, 1 minus 0.8602, you'll get 0.1398. Your N1 will be 100 and your N2 will be 93. Step 1 is to define the hypothesis. Your null hypothesis or HO will be P1 is equal to P2. And your alternative hypothesis or the HA will be P1 is not equal to P2. Our claim will be the alternative hypothesis, which is P1 is not equal to P2. Since the problem is asking if there is a difference in the population means. Step 3, the alpha. The alpha is already given, which is 0.01. This will also be a two-tailed test like problem number 1, since the problem is still asking for a difference. If by chance that a problem is asking if a proportion is greater than or less than another proportion, then that will be the time that it will be a one-tailed test. Step 3, the critical z-values. Since it is a two-tailed test, we will have two z-values, a positive and a negative one. Now using your t-table, locate your alpha 0.01 in the two-tailed part and you'll get positive negative 2.576. Step 4 is to solve. Using the formula z is equal to p1 minus p2 all over square root of p1 q1 over n1 plus p2 q2 over n2, substitute the values that you have. Your solution will now be z is equals to 0.85 minus 0.8602 all over square root of 0.85 times 0.15 over 100 plus 0.8602 times 0.1398 over 93. Using your calculator, you will get an answer of negative 0.20. Step 5 is to graph your solution. Draw a normal curve. Then, plot your critical z-values, which are positive negative 2.576. Shade those regions. And then, plot your answer of negative 0.20. Since our answer did not touch the shaded region, we can now accept HO and reject our claim, which is the HA. Step 6 is the conclusion. Since we accept HO, we can therefore conclude that there is a difference in the population means. Problem number 3. A new kind of flu breaks out throughout the world. Doctors have been testing two flu drugs, WX and YZ. Drug WX works on 41 people out of a sample of 195. Drug YZ works on 351 people out of a sample of 605. is drug WX more effective than drug YZ? Use alpha is equal to 0.05 level of significance. The given P1, 41 over 195. Divide it and you'll get 0.2103. P2, 351 over 605. Divide it and you'll get 0.5802. To get Q1 and Q2, you must subtract 1 from your P1 and P2. Q1, 1 minus 0.2103, you get 0.7897. Q2, 1 minus 0.5802, you get 0.4198. Step 1 is to define the hypothesis. Your HO or the null hypothesis will be P1 is less than or equal to P2, and your HA or the alternative hypothesis will be P1 is greater than P2. Our claim will be our alternative hypothesis since the problem is asking if drug WX is more effective than drug YZ. This simply means that the problem is claiming that a proportion is greater than another proportion. Step 2, the alpha. The alpha is already given, which is 0.05. Now this will be a one-tailed test since the problem is asking if a proportion is greater than another proportion. Step 3, the critical z-value. Since our problem is a one-tailed test, we will only have one critical z-value unlike a two-tailed test. Since the problem is asking if a proportion is greater than another proportion, our critical z-value will be positive. Using your t-table, locate the alpha 0.05 in the one-tailed part and you will get positive 1.960. Step 4 is to solve. Using the formula z is equals to p1 minus p2 all over square root of p1 q1 over n1 plus p2 q2 over n2. Substitute the values that you have. Your solution will now be z is equals to 0.2103 minus 0.5802 all over square root of 0.2103 times 0.7897 over 195 plus 0.5802 times 0.4198 over 605 Compute it using your calculator and you'll get an answer of negative 10.44. Step 5 is to graph your answer. Draw a normal curve and then graph your critical z-value, which is positive 1.960. Since it is positive, it should be on the right side of the graph. And then shade it. Now plot your answer, which is negative 10.44. Since our answer is very much far away from the shaded region, we can accept HO. Our answer did not touch the shaded region. This simply means that a proportion is not greater than the other proportion. Perhaps it is less than or equal to the other proportion. Step 6 is to conclude. Since we accept HO, we can conclude that drug WX is not more effective than drug YZ.
Now we have solved 3 different problems about Z-test for 2 proportions. Again, Z-test for 2 proportions allows you to compare 2 proportions to see if they are the same. If you see a problem that has 2 proportions given, keep in mind that it is already a Z-test for 2 proportions. Let's have a recap on the steps that you need to solve the problem. Number 1 is to define the hypothesis. Number 2 is the alpha. Number 3, the critical z-value. Number 4 is to compute. Number 5 is to graph the given. And number 6 is to conclude your problem. Thank you for listening. Now on to the next lesson.